Hi everyone. You have the option of one of two things. You can go through and take the notes on your own without the video, or you can follow along with this video and notes. So we're picking up where we left off on Monday and Tuesday. For the metals, as you go down a group, reactivity increases. We already wrote that down. It's a big trend, and our other big trend is for non-metals. As you go down a group, reactivity decreases. Now there's a link at the bottom of this slide. It's going to come into play when we do our lab. So you do not have to watch it right now. You will be watching it either on Thursday, Friday, or Monday, Tuesday. So here are your phases of matter. You already wrote down the two liquids, mercury and bromine. There are 11 gases that you need to know: hydrogen, nitrogen, oxygen, fluorine, chlorine, and all of your noble gases, which really makes it sort of easy because the noble gases we already know are gases. So you really only need to remember hydrogen, nitrogen, oxygen, fluorine, chlorine. Everything else on the periodic table is a solid, which means we are primarily made up of solid elements. Now we write them as solid, liquid, or gas, S, L, or G. And what you can do in your notes, use table S in the New York State reference table, find the melting point, find the boiling point, and determine, is it solid, is it liquid, or is it gas? Now when we draw these, and this is what we've already done before, a solid, definite shape, definite volume. It's got that particle diagram, a very geometrical shape. Liquid, no definite shape, no definite volume. Here it is, liquid, sort of fills the bottom of the container just like gravity. And gas, no definite shape, no definite volume. It will fill the entire space available. So here you go. This is what I was just talking about. Use reference table S. Standard temperature is 0. 0 degrees Celsius, and room temperature is 27 degrees Celsius or 300 K. We're going to get into those conversions a little bit later. You're going to look at the melting point and boiling point for an element. If room temperature is 300 K, if it's higher than both, it's a gas, lower than both, it's a solid, or in between your boiling, it is going to be a liquid. So check neon, mercury, and gold. I'm going to press pause. You're going to press pause right now. Get into your reference table, make sure you can determine whether something's a solid, liquid, or gas, and make sure it matches what we wrote down a few minutes ago about your periodic table, how many liquids, solids, and gases we had. Okay, we have already actually drawn this. It's on the bottom of page 1 or 2 in your note packet. If you would like to draw it again, you certainly may. This is a phase change for the first one. The second one is a chemical change. And we talked about it before. So liquid, we've got all of our water molecules at the bottom. When it turns into a gas, they spread out. A solid would be geometrically shaped. Air chemical change, we're starting with solid carbon, which is 2 greens, and 4 oxygens, which would be 2 oxygens and 2 oxygens. And when they combine, it makes carbon dioxide gas. Now when we get into pure and mixture, we've already done some of this, so let's just set it forth again. Pure is called a substance. There are set formulas, set ratios. A mixture, there's no set formulas, no definite ratio of compounds or components. My apologies there. So here you go. This is just the pure side. It's the same throughout. Definite composition. It's always the same formula. It is either element or compound. If it's an element, it's only one type of element. Remember, some are allotropes, some are diatomics. Those are still only one element. Oxygen is made of O2, one element. Ozone is made of O3, one element. Now, they cannot be broken down chemically or physically, and there's some particle diagrams. Letter A looks like a solid. Letter B looks like a diatomic gas. Now, press pause, write everything down if you need to, and then move on to compound. Compound, 2 more different elements chemically combined in a fixed ratio. That fixed ratio, good example is water, H2O. Always 2 hydrogens, 1 oxygen. Doesn't matter if we're talking about water, solid, liquid, or gas. Always the same fixed ratio. It can only be broken down chemically, sort of like decomposing. And here's an example with letter